Black holes are the largest things in the universe. Unlike planets or stars, they have no physical size limit and can literally grow endlessly. So how do black holes grow, and how large is the largest of them all? Let's start really small with primordial black holes. The smallest kind may or may not exist. If they exist, they are probably the oldest objects in the universe, older even than atoms. They would have formed just after the Big Bang, when the universe was so dense with violent energy. The smallest primordial black hole would be 1 trillion kilograms, the mass of a big mountain. And yet they would be no bigger than a proton. A primordial black hole with the mass of Earth would barely be larger than a coin. This makes them very hard to find, so we haven't actually observed any yet. They may even be the mysterious dark matter that holds galaxies together. Let's move on to stellar black holes, the kinds we know for sure are out there. To make a black hole, we need extreme conditions like supernova explosions or neutron star mergers. The smallest known black hole has 2.7 times the mass of our Sun. This creates a sphere around 16 kilometers in diameter, large enough to cover Paris. One of the largest stellar black holes is M33X7, currently eating a massive blue giant star bit by bit. As stolen matter spirals toward the black hole, friction heats it to shine 500,000 times brighter than our Sun. To grow much larger, black holes must devour many stars or merge with each other. We detected two massive black holes merging 17 billion light-years away. They released more energy in gravitational waves than all the stars in the Milky Way emit in 4,400 years. The new black hole they formed is 142 solar masses and about the size of Germany. Here we hit a curious gap in the scale. Lots of black holes up to 150 solar masses, then nothing, until we suddenly hit millions. The universe isn't old enough for supermassive black holes to form by just eating stars. Something else must have happened. Enter quasistars, hypothetical massive stars from the early universe. Our Sun is like a grain of sand compared to quasistars. Quasistars could grow to thousands of times the Sun's mass in the dense early universe. Their cores might have collapsed into black holes while the star was still forming. A deadly balance, gravity feeding the black hole, radiation keeping the star stable. These black holes could consume the quasistar for millions of years, growing massive. They might reach thousands of solar masses, wider than the entire Earth. These could have become the seeds for supermassive black holes. Now we arrive at supermassive black holes, the kings of the universe. Most galaxies have a supermassive black hole at their center. Our Milky Way has Sagittarius A star, with about 4 million solar masses. We know it's there because we see stars being thrown around by a seemingly empty spot. Despite 4 million solar masses, its radius is only 17 times our Sun's. The galaxy Cygnus A has a supermassive black hole with 2.5 billion solar masses. If it replaced our Sun, it would swallow all planets and stretch halfway to the solar system's edge. It creates radiolobes 500,000 light-years across, towering over the galaxy. Messier 87 has a 6.5 billion solar mass black hole, the first we photographed. This sphere of darkness covers our entire solar system. And yet, there is a scale even above supermassive black holes. Ultramassive black holes, perhaps the largest bodies that will ever exist. These have grown to tens of billions of solar masses. Their gravity powers quasars, shining brighter than thousands of galaxies. OJ 287 has an 18 billion solar mass black hole with another supermassive black hole orbiting it. 3 solar systems could fit inside it side by side. Let's end with the king of kings, TON 618. TON 618 shines with the brightness of 100 trillion stars, visible from 18 billion light-years away because it's so bright. It has 66 billion solar masses. Light would take a week to travel from the event horizon to the center. About 11 solar systems could sit inside it side by side.
It may very well be the largest single body in the universe, but it's probably even larger now since we only see what it looked like 10 billion years ago. Black holes are scary, mysterious, and gigantic. They will outlast everything else in the universe, growing larger and larger forever.